So yesterday afternoon, this is kind of what I was looking at. Looked out the window and saw these storm clouds rolling in, and it's super dry here right now. Temperatures have been hovering up, up over 90 most days, and we haven't had any moisture to speak of in well over a month now. So things are dry, and so I kind of went into the mode of let's set some sprinklers out in our kind of vulnerable areas, just in case we get any lightning strikes nearby and starts a wildland fire. This got me thinking about the topic of lightning, grounding. I've been asked several times about both subjects ever since I posted those videos about my antenna farm, what I do for grounding. And one thing I always hear from hams all the time is if you take a direct lightning strike, you're done for. Everything's toast. And think of it this way. Commercial radio sites, cell phone towers, TV towers, they take hits all the time. Lightning hits all the time. Those sites don't go down. Why? Well, they follow really good grounding practices, and they've got a plan in place to keep that lightning out of the building. That's the way you should approach it too. Keep the lightning outside of your shack. Don't invite it in the shack. And I see on forums all the time, guys posting that, oh, they've done this great, they put polyphasers or whatever brand you like, lightning protector, right inside the shack, right behind their desk. And from my point of view, that's probably one of the worst things you can do, is invite the lightning to come in through your shack to go back out to find ground. Now on our commercial sites that I deal with, the lightning protection is inside the shelter, just barely. It comes through an entrance panel, grounded at that point. So really the only thing you really have to worry about at that point is the center conductor. So somewhere within that, usually a few inches to a foot from where it's grounded at the entrance panel, there's a lightning protector to take care of that center conductor. So, you're kind of inviting it in, but not really, because the outside's where most of that energy is, and it's going to be grounded there, and it's also grounded out on the tower, top and bottom. Depending on the height of the tower, it's probably grounded in between there somewhere. If it's over 60 foot tall, usually there's several ground points depending on the height of the tower. And there's something a lot of the telecom industry follows, and I hate to say it, but Motorola developed this. I'm not a huge Motorola fan by any means, but the R56 grounding standards. And it's an excellent set to go by. You can get online and look these up. There's several places where you can download slightly earlier versions of it. Now, is it really practical for us hams to follow R56 grounding? Well, that's a tough one. I guess it kind of just depends on your point of view. Do you want to spend a whole ton of money on grounding, or do you just want to pay for insurance? I mean, it's kind of that simple. Me, I've kind of taken the middle ground and have pretty good luck with it. And some of our sites up on the mountaintops are not fully R56 compliant. We get as close as we can. Sometimes some of the sites, the buildings, there's no way they'd ever meet R56 specs. So we just do the best we can, try and get as close as we can to those specs. Like I said, look them up. They're very interesting. There's a lot of technical jargon in there. So if you really want a video done on that, let me know in the comments below, and I'll follow up with another video about those standards. But as mere mortal hams, can we accomplish a lightning-proof system? Well, we can come pretty close most of the time with, not a lot of effort, not a ton of money into it. You're going to spend some money, but, you don't have to go way overboard. You look at just my little station, how much money I have tied up in antennas, towers, feed lines going out to them, all that kind of stuff, antenna switching. Spending $500 for a good ground system's really not asking that much out of it. Now for smaller systems, you can get by, just $100 maybe, and you can really help yourself out here and hopefully keep that lightning outside of your shack. So let's go look what I've done. It's not R56 standards by any means, but I've had pretty good luck with it. And by the way, if you're using these things are your worst enemy when it comes to a good ground system. These things are not far behind. So this simple little box I made, I don't know, probably 12 years ago. Originally I was going to make it quite a bit bigger, and I never got around to expanding it. This was supposed to be temporary, and like most things, temporary becomes permanent. And it's just got a little sliding door to gain access to it. And this is mounted outside my shack. I drilled a 4-inch hole through the wall, and I know some hams are just freaks about not wanting to drill a hole through their wall to get coax in. Well, you can patch holes pretty dang easy, and it makes life so much simpler than trying to mess around putting them through windows and all that kind of jazz. If you've got more than 1 or 2 antennas, I suggest doing something like maybe like this. There's other ways to do it. I've seen those window kits where you can bring it in there. I used to have one way back when. The one thing I didn't like about it was it seemed to let bugs and cold air in all the time. No matter what I did, it seemed like, you know, after a month or so, the thing was letting bugs in. So I ditched that, went to this method, never looked back, and it's pretty simple. You drill the hole through the wall, stick a piece of conduit through there, and I use steel wool around that thing in case I ever get mice in here. They don't go through there. That was a mistake I learned the hard way. So let's look inside this thing. So I'm kind of ashamed of this thing right at the moment. I've been doing a lot of experiments with some solar stuff and some antenna switching. So this thing's just a rat's nest at the time being. But you can see I've got these big plates. These I think they're 1/4-inch thick copper plates. And I think these ones were made by Harger, both of them. This one might be a polyphaser plate here. And I can't remember what these things run. I'm thinking around 80 bucks, maybe 100 bucks. And usually they come with the copper, like this one here. The copper's already attached, and you just run it out to your ground system. Originally, these plates were going to be standing up vertically. That's the reason the funky bend in the coax right there is I was going to overhaul this and stand those up, and so these would be coming in sideways, but I just haven't got around to it yet. The feeds come in from the towers up through here and here, and then feed out on the bottom into the shack. And buried back, I can't get to it right now without tearing stuff apart, but back kind of off to the side here, there's another system for my rotator lines to go through. Kind of looks like this, and it was made by Polyphaser. So you can ground those lines and still provide voltage out to your rotators and control lines and all that kind of stuff. So that's a quick look, and this is outside my shack. I try and keep it lightning out here, not inside. And this thing here, in case anybody's curious, is just filled with water and RV fluid. It's a load dump for my wind generator for the time being. I had a regular one and it burned out on me, so that's my temporary fix until I get the other one fixed. It works really well, and the wind blows out here all the time, so you definitely need a load dump. So off of this, a big wire goes down. It's like a 2-aught wire. Goes down, and all the ground rods here are buried. I didn't want any of them exposed, and that's one area those stupid acorn nuts fail miserably. Is they're terrible about corrosion. If you use them, you can't bury them because you got to maintain them all the time. And there's a ground rod right there. There's another one probably about under that cement. Well, no, it's probably about under the edge of that cement. Then out there about another 8 feet, there's another one in that direction. And then this direction, there's one probably right about there, and another one out there. They're spaced about 8 feet apart. There's 8-foot ground rods. So that's the ground system right here at the entrance point. Now from here there also is about a number 10 wire running over to the service entrance on the house, and grounded to that ground point too. And of course the power company, they use those stupid acorn nuts, and I changed that and used a compression fitting. So let's go look at the tower ground real quick. So here on the tower, you can see I used a compression fitting there. Runs out to this ground rod where it's exposed, but down underneath here there's another connector just like this one, hooked to another piece of wire, and it's buried out, and there's 3 more ground rods out that way, and all 3 legs are the same way. There's 12 ground rods total on this tower. And these last 2 runs I did a hard line. I haven't got these grounded yet, and I'll try and put out a video on how you ground these. But these should be grounded to the tower, top and bottom. Coming up to this weed-infested Roan 25 that I hate to climb. It's similar to the other tower. You can see it's compression fittings going out to ground rods. This one's got 3 ground rods per side. It's a total of 9 ground rods in. A nice little fiberglass doghouse for cabling connections. And right up there is a 80-meter vertical antenna. The start of a 4-square that I have not got around to finishing yet. Right here's a 40-meter 4-square. Now these are a little harder to ground. I'm kind of using an air gap ground on these because you can't ground these directly, or it kind of screws up the antenna system. As you can see, my setup's not real elaborate. I've spent, I don't know, if I added it all up, I might have $400 to $500 wrapped up into that. Those little crimp compression fittings that I mentioned in lieu of these stupid things, those things range from, the ones that are crimped to the tower are around, I think, $8 a piece. The ones that connect to the ground rods are more expensive. I think they start about $20. And the fancier ones that have more connection points, you can get those up to about $60 or so. They're a one-use deal. Once you crimp those, there's a tool that looks like this that crimps these, and it uses about 6 tons, if I remember. I'm going off the top of my head, but I think it's around 6 tons of force in a very small area, and just smashes those things down. If you're compressing to other copper components, years later you can go back and cut those in half, and you can't tell where one component was compared to the other. Like, you can't tell where the ground rod connector starts and where that crimp connector is. It just looks like one hunk of metal when you're done. Just for an experiment, I pulled one up from a site that we took out. It was in the ground maybe 10 to 12 years, and I cut it because I didn't know if I believed the manufacturer's hype about these things. And sure enough, even after 10 years of being out there, there was no corrosion between the 2 components. Actually 3 components: the wire, the connector, and the ground rod all look like one hunk of metal. So I'm a firm believer in those things. You know, then there's Cad Welding. If you can do Cad Welding, it's great too. I've had some bad experiences with Cad welding. I've done quite a bit of it. Some folks will call it exothermic welding, whatever you want to call it. It's a great way to do it. It's just, I don't know if it's practical for every ham to use. These little compression fittings, you can buy those from a number of places. Look up Burndy crimp connectors. I think there's a couple other companies making them now. A lot of rental places now have those crimp tools for those. They may be the hand pump ones where you have to sit there and pump, but it does the same job. We use a battery operated one at work, but we do quite a few of these things. So for just the average Joe, go rent one for a day. I don't think they're like $30 or so to rent, and it'll do the job just fine. If you can't find a rental place that'll do it, many electricians have them and may rent them to you. You know, you just kind of got to ask around. Electricians are pretty stingy with tools, and I don't blame them. But those kind of connections are well worth the effort to go find a crimp tool to do them over these stupid things. Not to mention, these are terrible for RF grounding, and that's a whole other lecture we could get into about RF grounding. It's kind of a different beast. You got to kind of think of things a little different. But these things are your worst nightmare. If you're trying to get good RF grounding, these things are a no-go. And these kind of things, I see these used all the time on tower legs and poles and whatnot. Man, I just do not like these things. If you have to use them, then use them, but just remember, do not bury them, and you got to clean them once in a while. So I know somebody's going to ask, have I ever taken a direct strike here? No, I have not. I've been lucky. I've got storms that come through quite often. Several times I thought for sure that one of these towers was going to get hit, and I think it's got hit by the little stringers that come off the side. I'm almost positive that's happened a couple times. Never sustained any damage to radios. So fingers crossed my system's working. Just thinking here, a couple other things that I've heard of from hams from time to time is all you need to do is just disconnect all your equipment. Just unplug your radio. Take that RF connector off and you're safe. Not necessarily so. If you don't have any lightning protection outside your shack or right at the entrance point of your shack, guess what? That lightning's coming into your shack and it's going to go somewhere. It may get your radio, it may get your computer, it's going to go somewhere once it's in your shack like that. If you don't have somewhere else for it to go, it's going to come in and try and find a path to ground. And you've got stuff plugged in that shack through your electrical service, it's going to see it as a ground and away it goes. And for you guys that are not hams and you keep asking what's this shack thing, it's our space that we operate from. That for as long as I've known about, it's been called a shack. It's our ham shack. It's where we do our business. Not that kind of business. And back to that theory of if you get hit with a direct strike, everything's gone. Your radio's gone, everything's gone. Well, let me tell you from experience, we take lightning strikes on our radio sites all the time, and before we really knew how to ground the systems, we destroyed stuff left and right. We take out the radios, PAs, receivers, everything was toast. Solar controllers, they would be toast. Since that time back in the mid-90s when we used to have all that happen, we kind of learned more about grounding, took some grounding classes, started accidentally following the R56 standards, and then now we do follow the R56 standards the best we can, and we just really don't have any problems besides antennas, especially fiberglass antennas, collinears, little what we call baseball bats, no gain, little short antennas. Those get hit by lightning, they're pretty much toast. Sometimes the folded dipole type antennas, they'll survive. Sometimes, depends on how big the strike was. So yes, radio sites can and do all the time survive direct hits. The other thing I want to mention real quick before we wrap this up is tight bins on your ground system. If you noticed on my towers out there, most of the bins were kind of swooping bins down to the ground system. Same with outside of my little entry box out here. I try and keep those nice sweeps to them. They taught us that at some of these grounding schools. I've read some more white papers recently that say that may not be true, but I can tell you this, on a lot of lookout towers and radio towers, especially the older installations, the ground would come down and make a hard 90 over cement and whatnot before it got into the ground. And at those points, when those sites get hit by lightning, anywhere there's a sharp bend, they're extremely discolored. You can tell a lot of heat did something at that point. That lightning did something really strange right at that point. And I think that's the reason a lot of the manufacturers of lightning protection say avoid 90-degree bends, because it's liable to just shoot off at that point and go somewhere else, is the theory anyway. So we've always kind of followed that. And believe it or not, once we started doing that, even though we had lightning protection on before, once we got rid of a lot of 90-degree bends, our damage rate went almost to zero. So there's something to be said for it. Well, I just wanted to throw that out there real quick. Saw that storm roll in yesterday, and it got the wheels to turning about some questions that I've been asked about my ham station. So I thought I'd address that real quick just to show you what I do. And if you guys want more in-depth about grounding, let me know in the comments below, and I'll follow up with some more videos about grounding, get a little more in-depth into it. This is just kind of a basic overview of what I've done and what seems to work for me, and the standards that are out there that you can follow. There's other standards floating around too. It's just a lot of the telecom industry is following that R56 standards by Motorola. No, seriously, I'm not bashing on you Motorola guys much. They make great radios. They do. Calm down. So as always, thanks for watching, subscribing, hitting that little bell thing, and giving us a thumbs up once in a while. Have a great day. Forgot to mention, no, the lightning storm didn't make it to us. It kind of fizzled out about 20 miles away. It really looked like it was going to come in and hammer us, but it just kind of fizzled on us, which is okay. No fires.